Hi, in this video we will see that how we can work with matrices whose entries are complex numbers. Well, remember that all the matrices so far, the matrices had the entries either real number so we were taking the numbers from R or from integers modulo some n, so or from Zn. And we saw that all the work goes through and the computation you need is just as before, but now you're working with Zn or R. Now we want to consider the matrices whose entries are complex numbers. All the operations, all the work that we have done for real numbers, you can do exact same way for complex numbers. For example, adding two matrices, you add the corresponding entries. Multiplying, you do the matrix product, but entries are complex. While you're multiplying the entries, you have to do complex multiplication. I have prepared some examples just to show you that, well, there's nothing new but multiplying the entries or doing operations on the entries as we had before. Okay, let's see this example. We have two matrices A and B, and we want to find A plus B times A minus B. So let us start. A plus B and then A minus B. So we have now two complex matrices. 1 plus 1 is 2. 0 minus I is negative I. 2 plus I, well, 2 plus I is just 2 plus I. And then this is 1 plus 0 is just 1. This other one, 1 plus 1 is 2. This will be plus I, and then 2 minus I, and 1. Now we have two matrices, multiply them. The matrix multiplication is the same thing. But when you do the entries, you have to consider the complex multiplication. So first row, first column here, 2 times 2 plus minus I times 2 minus I. That's the first entry of the first row. Then first row, second column, 2 times I plus minus I times 1. 2 plus I, second row times first column, plus 1 times 2 minus I. And 2 plus I times I plus 1 times 1. And, well, as I said, everything as before, but now you're adding or multiplying two complex numbers. For example, look at here. Minus I times 2 plus I, it's going to give us minus I times minus I. It's going to give me negative 1 minus 2I. There's a 4 here. 4 minus 1 minus 2I. This is 3 minus 2I. How about this one? This is 2I minus I. This is going to be I. This is 4 plus 2I plus 2 minus I. 2 and 4 is 6. 2I minus I is plus I. And here we have 2I. I times I is negative 1 plus 1. These two cancel. This is 2I. And that's what we have. So you have to write at the end as one, each entry is one complex number in the form of a plus a bi. Okay, how about this one? Okay, so we have a, which is 1, 0, 2, 1, plus I. The scalars now can be complex numbers. 1 minus I, 0. And then square of that. This gives us 1 minus I times 1, which is 1 plus I times 1. This will be 1 plus I. 0 plus I times negative I. I times negative I is 1 plus 0 is 1. We are going to find the square of that at the end. 2 plus I times I is negative 1. So 2 minus 1 is 1. And 1 plus I times 0 is, this is 1. Now I have a matrix with complex entries and I want to multiply that to itself. And as you can see here, 1 plus I times 1 plus I, first row, first column, plus 1 times 1. The second one, 1 plus I times 1 plus 1 times 1. 1 times 1 plus I plus 1 times 1. And 1 times 1 plus 1 times 1. Very nice. And here now we need to do the computation here. Yes, 1 plus I times itself. 1 plus I, 1 plus I. This will give us 1 times 1, I, another I, plus I times I, which is negative 1. So negative 1, this guy is 2I plus 1. Here we have 1 plus I plus 1. This is 2 plus I. Here we have 2 plus I again. And here we have 2. And that's it, what we have. So let me just write this one as the standard form. And then we have what we have. How about B inverse? Well, B is what matrix? This is 1, negative I, 0. You can either do the Gauss-Jordan elimination method, BI, and then row reduce it. Here's I, sorry. Or in 2 by 2 case, you can do, you see that determinant of B, which is 1 times 0 minus negative I times I. This guy is 0 minus 1. I times negative I is 1. There's a negative sign there, so this is non-zero. So B is invertible, as we had for the real numbers. And then B inverse is going to be 1 over determinant of B. Switch these two entries, multiply off diagonal entries by negative sign. So this will give us 1 over negative 1, 0, I, negative I, 1. And that will give us 0 minus I, negative 1. That's it. Or we could have started with 1 minus I, 0, identity. And do the row operation. How do we find the row reduced row echelon form of this matrix? Yes. So if I multiply row 1 by negative I and add it to row 2, we will get 1 times negative I plus I is 0. Negative I times negative I, that will be negative 1. Added to 0, this is negative 1. And this is 0, sorry, not 0, that will be negative I, 0 minus I times 1, and 1 here, and then this is 1 minus I, 1, 0. And then what we do is that we multiply the row 2 completely by negative sign. So we have this. And now we want to get rid of that number. For that, we multiply row 2 by I and add it to row 1. This way we'll have 1 here, 0 here. I times I is negative 1. Added to 1 is 1 minus 1, which is 0. And here we have minus I plus 0. This is minus I. 0, 1, I, negative 1. And as you can see, this is B inverse. And you see that that's exactly what we found in the other method. So the operations are exactly same things, but the entries you're working with are complex. So you have to do complex multiplication, addition, and so on.